The purpose of this video is to introduce some of the features that should be considered for switches at specific layers of the Cisco hierarchical network model. It is important that you know the information presented in this video because as a network engineer, you may be responsible for selection and purchasing of network hardware. Improper equipment selection may lead to a slow LAN and decreased user productivity. A hierarchically designed LAN is divided into different functional layers. Each layer does its part to efficiently deliver frames to the intended LAN destination. In the Cisco hierarchical model, the access layer's main responsibility is to enable users to access the network. The access layer extends from a user's work area to the intermediate distribution facility, or IDF, and includes the switches where horizontal cabling ultimately terminates. The distribution layer serves as a consolidation point for access layer switches. When multiple IDFs are located throughout a building, uplinks from each of those switches terminate at a distribution layer switch. The distribution layer is responsible for policy enforcement and inter-VLAN routing. Finally, the core layer acts as the consolidation point for distribution layer devices and a high-speed, redundant network backbone. An example of a network core is the equipment that ties together the multiple distribution layer switches in a multi-building campus. Benefits of a hierarchically designed model include scalability, redundancy, performance, security, manageability, and maintainability. Because the different layers in a hierarchically designed network have different functions, the switches at each respective layer must be capable of carrying out those functions. One of the most important features that must be considered when choosing a LAN switch is performance. Characteristics such as port density, forwarding rates, and link aggregation capability will be more or less important depending on where in the hierarchy a switch will be deployed. Port density is merely the number of ports that a switch has. Port density can range from 24 ports in smaller fixed configuration switches to many thousands of ports, which is common in enterprise-level modular switches. Forwarding rates define the amount of data that a switch can process per second. Forwarding rates can range from full wire speed across all ports to any number of less than wire speed quantities. Wire speed is the data rate that each port on the switch is capable of attaining, either 100 megabits per second fast Ethernet or 1000 megabits per second gigabit Ethernet. The switches in this graphic are capable of running at full wire speed across all ports simultaneously. That is, their forwarding rate is equal to their port density times the bandwidth rate of each port. Access layer switches typically do not need to forward at full wire speed across all ports simultaneously. However, as bandwidth requirements increase in the distribution and core layers, switches with extremely high forwarding rates become more desirable. As the forwarding rate of switch models approaches full wire speed, the cost of the switch increases. Link aggregation capability enables a network engineer to combine multiple physical links into a single and higher bandwidth logical link. Cisco's implementation of link aggregation is called Ether Channel. Link aggregation helps to relieve bandwidth bottlenecks that occur on switch uplinks. In this graphic, 4 physical ports have been aggregated to form the single Ether channel link between switches D1 and C1. If each physical port performs at 1 gigabit per second, then the Ether channel performs at 4 gigabits per second. Contrast this with the single 1 gigabit per second link that exists between switch D2 and C1. The Ether channel that is configured provides more bandwidth to accommodate the needs of other access layer switches that may be connected to switch D1. Other features that should be considered when selecting access, distribution, or core layer switches include Power over Ethernet, or PoE functionality, and Layer 3 switching capability. PoE enables switches to supply power to access layer devices such as IP telephones or wireless access points. This relieves the network engineer from needing electrical outlets in the direct vicinity of such devices. Layer 3 capability enables a switch to perform forwarding based upon IP addresses rather than MAC addresses. Although beyond the scope of this presentation, Layer 3 functionality allows for faster packet switching than routers. This faster packet switching functionality is ideal for LAN environments where users expect extremely fast network performance times. Quality of service, or QoS, and VLAN support are also critical for today's converged networks. Now that you know about different features that should be considered when choosing a switch, let's look at the importance of those features when choosing a specific access, distribution, or core layer switch. When choosing an access layer switch, consider whether or not PoE is necessary to power any IP phones or wireless access points that may be in the network. Quality of service should also be implemented if IP telephony is present in the network. Also, access layer switches should ideally include VLAN capability. The access layer is where users connect to the network. Choosing a switch with sufficient port density is important at the access layer. Link aggregation should also be considered if your network has consistently high volumes of traffic. When choosing distribution layer switches, fast forwarding rates become increasingly important because those switches aggregate traffic from multiple access layer switches. Because distribution layer switches aggregate traffic, port density is not as important at the distribution layer as it is at the access layer. Layer 3 switching and link aggregation capability should also be considered at the distribution layer. If quality of service and VLANs have been implemented at the access layer, they should be continued in the distribution layer. Core layer switches should include 1 gigabit per second or even 10 gigabit per second links to accommodate the large volume of traffic that will traverse the network backbone. Layer 3 support, redundant components, link aggregation capability, and very high forwarding rates should also be implemented at the network's core. All organizations' network and equipment requirements are unique. For this reason, Cisco offers a variety of access, distribution, and core layer switch models with features designed to meet the needs of any size organization. There is much more information to consider when choosing a switch than what is presented in this video. For this reason, we suggest that you visit www.cisco.com or contact a Cisco sales engineer to research solutions that best meet the needs of your organization. We hope this presentation has been helpful in introducing you to some of the features that should be considered when selecting LAN switches.